Hello students, welcome to Easy BTech, your guide for BTech and beyond. In the today's lecture, we will discuss about BJT configuration, how the BJT can be used as a common base configuration, common emitter configuration and common collector configuration, and what are the characteristics in those configurations. Suppose a amplifier, transistor can act as an amplifier, and this amplifier has been divided into three kinds: common base configuration, common emitter configuration, common collector configurations, and three amplifier: common base amplifier, common emitter amplifier, common collector amplifier. And if you take a common emitter, which has a most application in power amplifiers and other amplification purpose, we use it. Voltage amplification, current amplification purpose, we may use a common emitter configuration. For a common collector configuration, voltage gain is high, current gain is high, we may use for the current amplification purpose. Common base configuration is used for the voltage amplification purpose. By that, we may say their comparisons and their advantages and what is their input and output behavior of the configurations, transistor configurations. Okay, students. Okay, students, we will start a BJT configuration. BJT configuration. Next, you can say when a transistor is connected, when a transistor is connected in a circuit, when a transistor is connected in a circuit, one of the terminal is connected to input, is connected to the input, and other terminal is connected to the output side, and the third terminal is common, and third terminal is common between input and output side, and the third terminal is common between input and output side. Okay, students, this is we will see next. Now suppose you may see how a BJT has three terminals. In the previous lecture we discussed all these things. A BJT has three terminals. What are those three terminals? Emitter, base and collector. Emitter, base and collector. Next. A BJT configuration. A BJT configurations are classified depending upon the depending upon the terminal is placed. Terminal is placed. Depending upon the terminal is placed. Suppose if base is grounded, it is known as common base. If emitter is grounded, common emitter. If collector is grounded, then it is known as common collector. These configurations are classified depending upon the common terminal between input and output. Depending upon input and output, which is the element is common, which are the terminal is common, the configuration is as classified in this manner. Okay, you can see now, students. We'll draw the structure. Now students, you can see the junction is JE junction, the junction is JC junction. Now it is emitter terminal, it is base, it is collector. Input is emitter, ground is base is grounded, output is collector. Okay, now it is a common base configuration. Similarly, you may change the terminal and you can make these configurations. Okay, now this input side, what we have, input current is IE, input voltage is VBE, and output current is IC, output voltage is VCB. Okay, this is grounded. This is a common base configuration. Generally, if we use a two-port network, now it is a two-port network, BJT. It is grounded. Input current I1, input voltage V1, output current I2, output voltage V2. Okay, it is a basic general two-port network parameters. Okay. Now from this, we have different types of two-port network parameters. They are Z parameter, second Y parameter, next ABCD parameter, H parameter, and S parameter. Okay, Z parameters are used in the electrical circuits, and Y parameters, impedance parameters, admittance, generally used for the electrical analysis purpose, and ABCD parameters used for the transmission lines, and H parameters especially used for BJT analysis, transistor analysis purpose. It is sufficiently used. And S parameters we used for the incident and reflection coefficient in microwaves. In microwave high frequency applications, we may use this S parameters are used in microwave frequencies were known as scattering parameters. H means hybrid parameter. Z means impedance parameters. Y means admittance parameters. These are the two-port network parameters. Okay. Next. Now here from this structure you can see, suppose common emitter or common base. For a common base, what is input node, output node? Common emitter, what is an input node, output node? For an, clearly you can see, for a common base, input is emitter, output is collector, ground is base. Means here, input is emitter, output is collector. Okay, common emitter means this is a structure of common emitter. Base, collector, emitter, MP and transistor. Common base means in this manner. Base is grounded, emitter, collector. Common emitter means input is base, output is collector. For common collector, input is base, output is emitter. Here the ground. Ground is base, ground is emitter, ground is collector. Input output nodes. Okay students, this is basically how the connections and what are the parameters classifications can be made. Next. A BJT is used as amplifier when a weak electrical signal is applied to the input terminal and a strong output, a strong signal, a strong electrical signal is taken from the output terminal. Okay, BJT is used as an amplifier when a weak electrical signal is applied to input terminal and a strong electrical signal is taken from the output terminal. Okay, and simply say classification of configurations. Classification of transistor configurations. Number one is common base configuration. Second, common emitter configuration. Third one is common collector configuration. Okay. Depending upon common, that is common between input and output or are grounded. Depending upon the common or between input and output or grounded, the configurations are classified. The configurations are classified as like this. Okay, if between the emitter to base, between the emitter to collector, base is common, common base. Between the base to collector, emitter is common, common emitter. Between the base to emitter, common is collector, then it is a common collector configuration. Okay, these are the transistor configurations. Next, all these configurations are explained from the input output characteristics, input and output characteristics, that we will study, input and output characteristics. Now you can see in the next slide we will see, that is BJT characteristics. BJT configuration characteristics. Configuration characteristics. Those are, first one is input characteristics, second one is output characteristics. Input characteristics and output characteristics. Now we know that H parameters are better suitable for the analysis of BJT. H parameters are better suitable for the analysis of the BJT. Okay, BJT. Okay. Now we will see what is that H parameters. That is V1 is equal to function of I1 comma V2. I2 is the function of I1 comma V2. This is an equation 1. V1 and I2 are dependent upon I1 and V2. That is why V1 and I are known as dependent variables. Dependent variables. Next, I1 comma V2 are known as independent variables. I1 and V2 are known as independent variables. Therefore, we know that to study input characteristics, that is the function V1 is equal to function of I1 comma V2. It means by keeping output voltage V2 constant, we can plot a graph between input voltage versus input current. that is V1 is a function of I1. V2 constant. Similarly, to study output characteristics, to study output characteristics, V2 is a function of, I2 is a function of I1 comma V2. From this, by keeping I1, that is input current constant, by keeping input current constant, we plot a graph between output voltage versus output current. That is I2 is a function of V2. I2 is a function of V2. This is a basic analysis of configurations. How we will start input and output graphs between common base, common emitter and common collector configurations, and basic two-port network analysis. Okay, students. In the next session, we discuss about